Alright, well here we are again, back with an introduction video to start us out in Chapter 8. Just so you guys know, we skip 8.1, we'll go right in with 8.2. We're going to be graphing in 8.2 and 8.3. With 8.2 we're going to graph simple but rational functions. So what is a rational function? It has this form, f of x equals p of x divided by q of x. Doesn't really make a lot of sense when we see it like that. Basically, your p of x and q of x are just polynomials. So, for example, a rational function could be y equals, let's say x plus 1 over x, that's an x, minus 2. That's a rational function. The graphs, you can see just a little example of a graph right there. You're going to have asymptotes like we had in our last ones. You've got your horizontal asymptote, and that's always going to be y equals some number, but we're going to have vertical asymptotes also. These happen to be at 0, y equals 0 and x equals 0. They could be, at different spots, so those get moved around a little bit. And then our function, we're just going to have these curves. So in general, our graphs are going to look the same. You're going to have a curve kind of within that box there, or in the corner. And just remember, your graph will never touch or cross your asymptotes. Alright, so we've got a few things to write down on this slide. You're going to have to find different things when you do your graphs. Vertical asymptote and behavior asymptote. So vertical asymptote, you will always set your denominator equal to 0 and then solve for x. So your answer is going to be in the form x equals some number. Your behavior asymptote, what you're going to do with this, and I'll go through an example on the last slide here, but you'll set up a new fraction with the leading term from the numerator over the leading term from the denominator, and then you're just going to reduce it. And this answer will always be in the form y equals. Now, the behavior asymptote, that's that horizontal asymptote that we talked about on the last slide. Sometimes it's not horizontal. That's what we'll see in 8.3 a little bit. So, we give it a term behavior just because it's not always horizontal. There is a special case with your behavior asymptotes, and that's what I have written over here in blue. If the degree, remember the degree is your highest exponent with x, if the degree in the denominator is bigger than the degree in the numerator, then your EBA, behavior asymptote, always defaults to y equals 0. So that's the thing to look for first, is the degree in the denominator bigger than the degree in the numerator. And if so, we don't even have to do this because we know it'll be y equals 0. You're also going to have to find x and y-intercepts. So what's kind of nice about this is you already know how to find x and y-intercepts. To find an x-intercept again, remember we plug in 0 for y, and then you just solve for x. Here we have a rational function off on the right. If you put in a 0 for y, this becomes a 0. Now it may look kind of complicated to solve because you have 0 equals some fraction. What you'll see in the video is a nice way out of this is if you make 0 a fraction also, that's going to allow you to, anytime you have a fraction equal to a fraction, cross multiply. And then we know that 0 times x plus 4 is 0, equals 1 times a negative 5x minus 18 is just negative 5x minus 18, and then we can solve for x. To find a y-intercept, you'll plug in 0 for x and solve for y. So these x's will become 0. So I know that we will have a negative 18 over 4, which does reduce to a negative 9/2. Now, the thing to know about your intercepts is how do you write your answer for an intercept? Well, an intercept is an ordered pair. So I can show you down here on the y-intercept since we already solved it. An ordered pair for this, we plugged in a 0 for x, and we got back a negative 9/2 for the y. So that's going to be my ordered pair for my y-intercept. So intercepts always write as ordered pairs. Alright, this last slide I just want to show you, you'll see a video on the graphing, but here's everything that you're going to do for your graphing. You have to find your vertical asymptote and behavior asymptote, your x and your y-intercepts. Domain and range is going to tie in a lot with your VA and your EBA. You're going to see a video on that. But just to run through this quickly, Vertical asymptote, set your denominator equal to 0, so 2x minus 1 equals 0, and we would solve that for x. And behavior asymptote, so that leading term over the leading term. The leading term in the numerator is a 10x, and the leading term in the denominator is a 2x, so 10x over 2x. And then we just simplify this, and we know that our x's cancel, and we have 10 divided by 2, which is 5. So this end behavior asymptote would be y equals 5. So if we were to draw that in, it's going to be up here at 5. By the way, you will have to draw in your asymptotes on these graphs. X and Y-intercept, plug in your zeros for x and y, depending on which one you're trying to find, domain and range. And then to get the points, you are just doing a table of values. So a lot of plug numbers in, get the points, plot your points. And because you'll get familiar with what the graphs look like, then that will give you a good idea if your ordered pairs are on track, because they should follow that curved pattern that we saw on that first slide. All right, that's in general, 8.2. You're going to see some videos going into more details with examples, but there you go.